the basic premise that we started with here is that this is a structure and it's free to take up any position it wishes to in space. And it does take up a particular position, and the shape that it takes up is called a catenary. It's used in suspension bridges and that kind of thing. It can be derived mathematically with one basic assumption. And that assumption is that every element in this structure will minimize its internal energy. If its internal energy is minimized, mathematically you find that this string equals a catenary, or this chain in this case. Now, every structure in the world, including your spine, under the influence of gravity, takes up its minimum energy position. And this is a simple case, but if I change the energy of one element in the string, of one element of this chain, by raising it above its energy down, I increase the energy at this point. But surprisingly, and maybe some amazingly, I have changed the energy of every element in the string, or in this chain, and I've changed the shape everywhere but at the two endpoints. And that's what a fixation is in your spine. It's a different energy level in the spine, and it causes, or can cause, the shape of the spine to be abnormal, or not its minimum energy. Everybody has an optimum shape of their spine. You grew up with it, it grew up with you. If I remove this fixation, then this chain returns to its optimal energy, minimum energy configuration. Now, your spine, if I remove the fixation in it, it does not necessarily return bingo like this. It will return more slowly because it's surrounded by all sorts of viscoelastic material. And if I put this chain in a vat of honey and took this away, it would return, but it would return much more slowly than it does when I just drop it. Now, the chain can be instructive because if I have a fixation at this point, and I release that fixation, but I've got another fixation here, this one has a tendency now to be unmasked by this first one. This was now masking the second fixation. If I remove the first fixation, I show the second one. This often happens when you're analyzing a patient. You analyze it, you adjust the fixation you find, and you see other fixations that you didn't see before. The reason is that they've been unmasked by removing that first fixation. If I have a fixation, fixation in this case doesn't change the shape of the curve. There's a fixation right at this point because I put one there, and you could only see that fixation on motion studies. But the instrument that comes down through here will pick up this type of fixation as well. Here's a fixation that is due to muscular interference. I'm up here, I'm fixated, I'm out of alignment. What do I do to get this back? If I just pull this back, I've got to change the musculature around that fixation to allow this to achieve its original minimum energy configuration. How do I do that? Well, one hypothesis is that by a sharp impulse to this muscular system, you stimulate the Golgi tendon complex, which causes this whole muscular segment to relax, which allows the spine to return to its original optimum shape. If you have several fixations and you see them, 1, 2, 3, you can sometimes see the major one by simply changing the patient's position. And if you have the patient all the way to flexion and you've got a series of fixations, bring the patient back a little bit and then retest it. I think it gives a marvelous way to explain to a patient. I had a chiropractor come back to the office the other day, and he stopped by the office, and I showed him this, and he said, I got in the office, and I didn't have a chain. I got to get a chain. It's so great for being able to explain to people what's going on. And I think it is a step in the direction of explaining in terms that people can more readily understand what you're doing when you release fixations and you get a spinal configuration change.
You laugh, but if you sell us the little chain and the little gadget, we'll go back and do this.